Welcome to this explainer. You know, when we picture the Middle East today, we see these vast, rolling desert landscapes, right? But beneath all that sand lies literally the engine of our modern global energy system. It's wild to think about. How on earth did that happen? Well, it definitely wasn't by chance. Today, we're going to unpack the exact scientific timeline and the frankly mind-blowing geological lottery that played out over hundreds of millions of years to create the largest fossil fuel reserves on the planet. Let's get right into it.
Okay, here is our roadmap for today. We'll start with the oil and desert puzzle, then look at its origins from ancient seas, how we go from plankton to petroleum, the perfect storage structure, some huge natural advantages, and finally, what this means for the future of global energy.
All right, kicking things off with Section 1, the oil in desert puzzle, which really is a massive geologic paradox.
So here's the core question we have to wrap our heads around. How exactly did a bone-dry landscape end up hiding actual oceans of liquid fuel underneath it? It feels completely counterintuitive, doesn't it? Usually when we think of rich biological resources, our minds jump straight to lush rainforests or coral reefs, definitely not endless stretches of sand. But as we'll see, geological studies show this setup is the result of a crazy, highly unique combination of natural factors that you practically won't find anywhere else on Earth.
Just to give you a sense of the sheer, unimaginable scale we're talking about here, take Saudi Arabia's Ghawar field alone. 170 billion barrels of crude oil. That is 170 billion. It is the single largest oil field in the world, stretching way beneath the deserts, right to the Persian Gulf. Obviously, a reserve that massive has completely rewritten international politics. But from a purely scientific point of view, a colossal pool like that doesn't just magically appear.
Which brings us to Section 2, Origins from Ancient Seas, or the Ancient Ocean.
Okay, so you have to completely reset your mental image. Hundreds of millions of years ago, the land masses of today's OPEC nations were completely unrecognizable. Basically, they were submerged beneath this vast, warm, shallow sea. And according to analysis from Scientific American, this ancient marine ecosystem was just absolutely teeming with life. Think of it as a giant biological engine churning out unimaginable amounts of organic matter, mostly in the form of tiny microscopic marine life, plankton.
Moving right along to Section 3, changing plankton to petroleum. Basically, nature's perfect recipe. So how does a tiny organism become fuel? It's basically a slow-cooked recipe that takes millions of years. First, all those countless microscopic plankton naturally died off and sank to the ocean floor. Over eons, they piled up, forming these incredibly thick layers of carbon-rich mush. Now, step 3 is the real kicker. The environment down at the bottom had almost zero oxygen. Because of that, the organic material couldn't decompose. It didn't just rot away like it normally would. It was perfectly preserved. Finally, tectonic shifts buried these layers deep underground, where insane heat and crushing pressure literally cooked this organic matter into hydrocarbons.
But here's the really crucial part. The Middle East had the exact perfect burial depth and temperature to produce oil. Geologists call this the oil window. It's a very delicate balance. If the sediment was buried too shallow, the cooking process just wouldn't finish. But if it went too deep, the extreme heat would have completely vaporized those complex organic chains, leaving us with nothing but natural gas. The Middle East managed to hit the absolute sweet spot, and not just in one tiny area, but across a massive geographic region.
All right, Section 4, the perfect storage structure, or how the Earth trapped all this oil. Listen, creating the oil is only half the battle. You also need a container to keep it in. Millions of years ago, the Arabian and Eurasian tectonic plates slammed into each other. It was an incredibly violent collision that actually pushed up the massive Zagros Mountains. But even more importantly for us, it created what's called a foreland basin. Think of a foreland basin as a gigantic subterranean bowl. This crash compressed and bent the sedimentary rocks, creating this perfect underground depression to catch and pool the liquid hydrocarbons into massive reservoirs, rather than just letting them leak away.
Now, because oil is lighter than water, once it forms underground, it desperately wants to float up to the surface. And if it actually reaches the surface, it degrades and it's completely lost. But according to the U.S. Geological Survey, the Middle East developed these incredible natural traps. We're talking massive geological folds, giant domes of solid salt, and thick, heavy layers of impermeable rock. Basically, nature built giant subterranean Tupperware lids, locking the oil tight inside porous rock layers way deep down. But wait, there's more. Even with the perfect bowl and the perfect lid, this trap had to survive millions of years. In a lot of other places on Earth, massive oil reserves formed, only to be totally wrecked by violent tectonic activity later on.
An earthquake shatters the rock lid, or a volcano just incinerates everything. But the Middle East? It experienced a phenomenal, almost unheard of level of geological stability. For tens of millions of years, these underground vaults just sat there, completely undisturbed. That absolute stability is exactly why these reserves survived intact.
Let's look at Section 5, Natural Advantages, diving into the economics of geology.
So why is Middle Eastern oil so incredibly cost-effective to extract? The U.S. Energy Information Administration points out that the region is heavily dominated by conventional oil reserves. Because this oil is trapped under such massive natural subterranean pressure, when you drill a well, you don't really have to work for it. The pressure acts like a shaken-up soda bottle, pushing the oil right up to the surface for you. It is highly accessible. Now contrast that with unconventional sources like shale or tar sands elsewhere. Those require immensely complex, highly expensive technology just to squeeze the fuel out of the rocks. It's night and day.
That intense natural pressure and easy accessibility, that is exactly why the Middle East has been the undisputed heavyweight champion of global oil production for decades. To put it in perspective, at times, the region has pumped out over 24 million barrels of oil in a single day. 24 million! That staggering output is literally the foundation of the global energy supply chain.
Finally, bringing it all together in Section 6, the future of global energy and the geological lottery. When you really look at it from a scientific perspective, this accumulation of oil is the result of a multi-million-year perfect storm. The Middle East basically bought the winning ticket in the greatest geological lottery of all time. They flawlessly hit every single necessary condition. They had the massive organic matter from ancient plankton. They got the absolute perfect depth and heat to cook it. They had the foreland basins and rock lids to trap it. And, crucially, they got tens of millions of years of total tectonic peace and quiet to preserve it. If literally any one of those factors hadn't lined up, the mind-boggling energy wealth of the modern Middle East simply would not exist.
So I'm gonna leave you with this final thought to chew on. Today, our world is standing at the edge of a massive, unprecedented energy transition. The role of fossil fuels is for sure going to evolve. But given the sheer, overwhelming scale and efficiency of the reserves sitting beneath the Middle East, how will the legacy of this ancient geological phenomenon continue to shape geopolitics and our global infrastructure? It's a massive question, and honestly, the answer is going to define the next century of human progress. Thanks so much for joining me on this explainer, and hey, keep questioning the science beneath our feet.